Today we're going to round out our applications of the integral with surface area of revolution. So if we take a rectifiable curve, okay, which remember was continuous and smooth and differentiable over an interval, and now we rotate that curve around a line. Okay, you can see what happens here is at each point we kind of get these circles. And here you can see we almost get ribbons that go around the outside of that volume.
So is this like the surface area of the curve?
What is that noise? Aaron.
You can go grab some water.
Okay. I will.
I think you dialed the wrong line.
What?
No,
Hold your breath for 20 seconds and then breathe in more air and hold your
yeah,
breath.
the back lines.
No.
Mr. Potter.
Just depends which way you look at it.
Oh, I see 2 pi r times the circumference.
Okay.
Well,
Now it's just all.
What is that? Why is it in the middle of the arc?
the arc length is the length.
Okay. So I just picked one little ribbon, and we can find here, okay, the surface area of the ribbon by taking 2 pi times the integral of the radius times the arc length. So when we think about circumference, it's 2 pi r, right? And then if we want to include this ribbon, we just multiply it by the arc length. And then that's going to be the same.
Oh, because it's
Okay.
area times width, right?
Area times width. Yep. And so here you can kind of see the whole solid here. And so the surface area is all the way around.
So the ribbon, does that represent the radius?
Okay. So the radius is going to be from the axis here up to here. There's your radius.
And when does it then?
And then right here is your arc length, which is what we spent last time finding. Okay, make sense? There's your radius. And the arc length. So when we look at the formula, here we have S for surface area, and it's 2 pi, the integral from a to b, of the radius times the arc length. And so the arc length is kind of what we found last time. So if we have a horizontal axis of revolution, let's go ahead and just make some sort of rectifiable curve here. And we'll just call this f of x.
Wait, that line is at that?
Mm-hmm. So if we revolve this, you can kind of see the resulting shape. Now if we're looking at this, what would our radius equal?
Function of x.
Function of x. Okay? And then arc length is still the exact same thing. Now if we go around a vertical, okay, it's kind of weird because we're still going to take from A to B. It's a little bit different than what we've been dealing with. Now our radius is just going to equal x.
And you take the x.
So it's going to be the x-coordinate right here.
The center of it, or
Just there.
Well, it's going to be the radius all the way along. That's why we're doing the integral. So it's the sum of all the different ones. Now it turns out that the arc length is still based off of f of x. So the only thing that changes here in going around the vertical axis is the radius.
where it was y is now x.
Mm-hmm. We'll see some examples of this here. So I'll highlight the differences for you.
In our other area equations, is there 2 pi as well?
Mm-hmm.
So in all
For the
area
shell
ones-
method.
So in all the area ones, we have 2 pi?
Well, this is the only area one. This is the surface area of a revolution. So what we were doing before was finding the volume of this.
Did we have 2 pi in that though, right?
That was when you used the shell method. Okay, so this is just a little bit different, but the only difference between a vertical axis and a horizontal axis is your radius. You still find arc length the same way using A and B and your function right there. So let's look how we do this. So it says find the area of the surface formed by revolving the graph on the interval around the line. So here is x cubed. And we want to revolve this around the x-axis. So in looking at this, all we need to do here is identify the radius. And what does r equal in this case? X cubed. Good. Then the only other thing that we need to find is f prime of x so that we can find the arc length. 3x squared. Okay, so those are the two things you have to find, and now we can plug it into our surface area formula.
Is that what we do on the quiz? Is take prime of x?
Mm-hmm. So here we get 2 pi. It's the integral from 0 to 1. And then we're going to multiply the radius, which is x cubed, and then times the arc length portion. And this is what you're doing on your quiz today. And that's 1 plus f prime squared. Squared, yeah. And there we go. So now you can put this straight into your calculator. You could square it if you want to make it a little bit easier on yourself, typing it in. So 9x to the 4th here. All right, so we're going to have 2 pi. Yeah, we could do the 2 pi at the end. So math 9 and x cubed times square root of 1 plus 9x to the 4th comma x, comma 0, comma 1. Looks like I have the right amount of parentheses.
I think you need one more in the beginning.
Okay, so this one right here is going to correspond with this one at the end. This one and this one match up. This one and this one match.
Oh, you're right. Okay.
And then inside the square root. Okay. Now we could see if that's going to be a fraction, and it's not. And so now just go ahead and multiply by 2 pi.
3.5.
We get 3.563. And of course this would be measured in square units, whatever those happen to be. All right. And our second and final example of the day.
We have time to grade our quiz.
Maybe.
We have time to do it.
Here we have our function of x is x squared. We're going to go from 0 to 2 pi. Or not 2 pi, root 2. I want to go from 0 to root 2 about the y-axis now.
How do you find out what R
That's what we're going to look at right now.
is? It R equals X, so would it just be like 1 or something?
Okay, so here's your radius. Okay. Now because we're going to find our arc length using a function of x, our radius here is just going to equal x. All right, does everybody see how this length is x at every point along that curve? All right, because if you trace it down, it corresponds with x, so the radius is x. Okay, so y-axis is vertical, and so the radius is going to be x. Because it's the distance from here to here, and that distance is x. Right? It corresponds to the x value down here. So if I went from here to here, the radius would be 1. Okay, so it's going to be x all the way along there. Then the only other thing we need is the derivative of our function.
Can you make f of x y and then solve for x or no?
You could, but you don't need to.
Okay.
That's what's kind of nice about this one, is you still just deal with f of x. If it came f of y, then you could do it that way too. But we'll just leave it as this, so our derivative is 2x. And so our surface area will be 2 pi times the integral from 0 to root 2 of our radius and then times our arc length portion. Okay. All right, and so let's try this here.
Calc classes at SCC. Sounds like an arrow.
Yeah.
Sounds like an arrow. Go to the line.
This one we do get a fraction.
But we are planning to get a ton of people to come for one match and just that when we come to the next week.
So you should get 13 pi over 3. What you got?
6 pi over 6, which is 13.
Black gold slash just like
Do you prefer to leave it with a fraction in pi or decimal?
You should be adept at leaving in terms of pi,
Yeah.
Divided by 2.
because if you come to a multiple choice test, you know it will have
Being a fraction.
exact answers. Of course, you could find all the answers on a calculator and then match them up, but that just takes a little bit longer.
Quiz.